One more strategy that is necessary to share in an introduction to Singapore math is this one strategy they use for solving word problems. And it's called model drawing, bar modeling, the model method. You'll see different names. But since they learn in English, starting in kindergarten, all math is taught in English, you'll find that their math program is very, very concrete and visual. So this is a method taught to children so that they can not only solve the word problem but understand it. So I'm going to walk you through exactly how I teach teachers and children to do model drawing. So first of all, this is a third grade word problem from Singapore, and it's called a comparison one with multiplication. So Carla and Jerome kept track of the miles they ran over the weekend. Carla ran 3 times as far as Jerome. If Carla ran 6 miles, how far did Jerome run? Well, when doing model drawing, I ask students, first of all, once we've read it, we have to figure out what are we being asked to solve. So I have students underline the question. And then what do? They go down to the bottom of the space. And if you want to work along with me there, in Cyberville, please do. So Jerome ran blank miles. We're going to focus on what it is we're solving. And then what we do in model drawing is we have to determine who and what we're talking about. Older students can call them the variables. Well, we're talking about Carla, and who else? We're talking about Jerome. So we write their names, and then we're talking very language-based. They learn to use possessives. We're talking about Carla's miles, and we're comparing her miles to Jerome's miles. Again, emphasis on understanding. And in our model, we always begin with one reason you'll hear model drawing we call a unit bar. And what I'm going to do is, it's like a bar, and it's called a unit bar because I can use it as a unit or divide it into units. And my pen's just a little wiggly there. But I want you to notice something I've done. When doing model drawing and teaching it to children, I'll ask them, do you notice how I've given Carla and Jerome unit bars of equal size and value? Then I ask them, did they run the same? And the children say, no. And then I tell them, let's make it correct. And we do that by going back and rereading the problem and modeling it one sentence at a time, like this. Carla and Jerome kept track of the miles they ran over the weekend, period, stop. I read punctuation. I ask them, is there anything to add? No math to add. Carla ran 3 times as far as Jerome, period, stop. We need to now adjust our model. Right now it looks like Carla ran the same, so let's add another unit of equal size and value. What does it show now? 2 times or twice as far as Jerome. That's not correct. Let's add another unit of equal size and value. Now what does it show? Carla ran 3 times as far as Jerome. Do you notice how the model exactly matches the language in the problem? And for older students, too, you can do the reciprocal. Carla ran 3 times as far. Jerome ran 1/3 as far as Carla. Okay. If Carla ran 6 miles, comma, pause, and let's add that. And guess what? Students learn where to put the information. We're going to put the 6 next to Carla. We can check that off. How far did Jerome run? Question mark. Well, we want to know Jerome's total. So now we have drawn a complete model of this word problem. When the question mark goes in, it's time to solve it. So then I have students step back and look at the model and tell me where you see a number. And you see it next to Carla. Now watch what else. Again, we're in a 3rd grade problem, so they would have learned this. You see those 3 equal units? First they'd even write out units. 3 equal units equals 6. Then what they learn is to use a U, and they would have learned to, with manipulatives that I can find, how many are in each by dividing, in this case, 6 by 3. 1 unit, 1 unit equals 6 divided by 3, or 1 unit equals what? 2. Sorry, hope I didn't confuse you there. So now what we're going to do is we're going to go back and add this information to the model. Do you see how immediately we can see it makes sense? 2, 4, 6. Then you ask the students, well, how does this help us with Jerome? we have this wonderful mathematical conversation that these are equal units, so Jerome's unit must have a value of 2. So how far did Jerome run? He ran 2 miles. How many more miles did Carla run than Jerome? 4. Okay. So this is a 3rd grade model drawing problem. We did one. They would do numerous of these. And the other one I want to show you is end of 4th grade, beginning of 5th grade. And it is a word problem that involves, first of all, a fraction of a total amount and then a fraction of a fraction. It goes like this. Mrs. Walsh made 300 cookies. She sold 3/4 of them and gave 1/3 of the remainder to her neighbor. How many cookies were left? Now, I don't know how many of you teach word problems, but I have kids who remember they needed to be somewhere else at this point. But watch what we're going to do. We're going to say, okay, let's use the model method and have it make sense. How many cookies were left? Well, there were blank cookies left. This is what we're trying to solve. And we're talking, who are we talking about here? We're talking about Mrs. Walsh, and we're talking about her what? Her cookies. So once again, there's that possessive, and we write our who and our what, or our variable. Now, before we had 2. This time we only have Mrs. Walsh and her cookies. We're really talking about her cookies. So now what we're going to do is just give Mrs. Walsh a unit bar. And that unit bar represents all of her cookies. But remember what we're going to do now? We're going to go back and reread the problem one sentence at a time. It goes like this. Mrs. Walsh made 300 cookies, period, stop. So what did we just learn? Total, guess what? We're going to put that total to the right. So she made 300 cookies. We've got that added. She sold 3/4 of them and gave 1/3 of the remainder to her neighbor, period, stop. Here's where we say to kids, too much information. Let's chunk even more. Let's start with just she sold 3/4 of them. Now this is what I do. Teachers can use language to guide students' thinking. I'm going to say part. What part? 3/4. So how many total units do we want to divide our unit bar into? 4. And out of the 4, we're talking about what? We're talking about 3. And what did she do? She sold. Now, I want you to look at this visual model right now. You can see she sold 3/4 of 300 cookies. But then it says she gave 1/3 of the remainder to her neighbor. Then you ask the student, did she give 1/3 of all of them? No, 1/3 of the remainder. Well, where are the remaining, or where is the remainder? It's right here. It's this final unit. So this is the remainder after she sold them. Now, again, in model drawing, some of you teach students that you could do that all in one bar. But what they do, they always focusing on understanding. So we're going to bring down just that portion of the unit bar that represents the remaining cookies right now. And then I'm going to go back to help the children learn to ask themselves, did she give all of them or part of them? She gave part of them. What part? 1/3. How many total units? 3. Developing that understanding of numerator, denominator. Out of the 3, she gave 1/3 to her neighbor. Let's use N period for neighbor. Now, you see this model? You can see she sold 3/4 of the 300 and gave 1/3 of the remaining ones to her neighbor. How many cookies were left? Well, we go down, and the only units that aren't identified are these 2. So these are the cookies that are left, and that is our question mark. We need to find the value of those 2 units. As soon as the question mark goes in, it's time to solve. And with this problem, I'd ask the students again, well, where do you see a number? And we see the 300, and that represents all of the cookies. But I want you to notice, how many equal units to the left? 4 units equal 300. And we find the value of 1 by taking the 300 and dividing by 4. And I'm going to share with you one mental math strategy a number of students learn is to divide by 4. You have the number twice. So let's try it. What's half of 300? Do I hear 150? What's half of 150? Do I hear 75? Great. Let's put 75 in here. Now, how many remaining cookies do we have? 75, but watch what I'm going to do. I can put that to the right of that, just that unit down below that represents, the unit bar that represents the remaining cookies. Now, what do we know? That 3 equal units equal 75. 1 unit equals 75 divided by 3, or 1 unit equals 25. And kids would, obviously, depending on what level, they would show different ways of getting to that answer. And then I want you to look at that. Now we have 2 groups of 25, so we can clearly see that Mrs. Walsh had 50 cookies left. Pretty complicated problem, but when students do these and do a number of them, they start to picture the word problem as they read it. In Singapore, they would say, kids cannot visualize on their own. We must teach them, and we teach them by drawing pictures. Robert Marzano, in his book, these strategies that work, he talks about students need to draw pictures and interpret them to get the mental images. So, as I pull this together, I've shared with you a few strategies that I think are very powerful that help bring about these benefits that you hear. I don't know how many of you saw the New York Times article that came out on October 1st. It was a front page article about some schools in New York making math as easy as 1 pause, 2 pause. And basically, it says what I believe, that Singapore math gives students a solid math foundation upon which to build increasingly complex skills, and it makes it less likely, and this is so important, it makes it less likely that they will forget and have to be retaught the same thing in later years. When I was in Singapore, they shared this quote, and I believe it to be true. So I'm going to end my portion, except for the questions, with this quote by Franklin Roosevelt. We cannot always build the future for our youth, but we can, and I believe we must build our youth for the future. So I thank you for attending. I'm going to turn it back to Tom, and we'll do questions.
Thanks, Char. That was great. And thank you, folks, for the questions that you've sent in. The first question has to do with existing content. I'm using everyday math in my classroom. Will I still be able to use Singapore math strategies?
Absolutely. It is these strategies, as I shared with you, I shared them with you. I don't know how many of you were thinking, I can use this with a student in my classroom. So I have a good friend who's also a Singapore math trainer who she is a full-time classroom teacher, and she uses everyday math, and she supplements with Singapore math. You can supplement any math series. They are best teaching practices.
Okay. The next question, as a first grade teacher, would I be able to use these strategies?
First grade, absolutely. Those number bonds are very powerful, but I only showed you the tip of the iceberg. I do believe that whenever, with today's students, we have so many differentiated needs, that the more strategies we have, the more ways we teach, the more students we reach. So definitely.
And the next question, if my fifth grade teachers start using these strategies and the children have not had them in previous years, what challenges does that present?
That's a great question, and it's one I'm frequently asked, actually. I kind of answer it this way. I'm an adult who in the last 10 years learned this, and it has had a powerful effect on me. So I believe it is helpful to anyone at any age to learn it. Now, what you need to do, though, is if you are working with a grade level who's never seen this before, is I recommend always starting with content that is very easy. Remember that if you do model drawing, nothing in that word problem should be brand new to the child. It should be practice.